Hello, fellow curlers. This is my presentation for the Curl Up 2022 in San Francisco, where I will hold this presentation via video link, hopefully, if everything works well. But this recording I do as a backup and to get some practice. Welcome to my little curl. I talk about Apache, curl, Apache, and a Tailscale network. And what we are doing is we will cook ourselves our own little global internet, and using Tailscale and a little bit of Apache and curl to make this happen. Tailscale. Tailscale is a company which offers VPN services in quite a new way, at least for me. Its business is offering this to enterprises, and it has a free tier to individuals. And they promise to keep this free. We heard this before. However, their CEO is a Canadian, so it might be true. What makes Tailscale unique from other VPNs? Tailscale is built on top of Wireguard, which is a state-of-the-art peer-to-peer networking software. Wireguard basically works as shown in this little diagram. You have two machines, A and B, which you want to connect via Wireguard. They have each a public IP address. You generate a private public key on each of the machine, exchange the public keys, and then you have a tunnel, a VPN tunnel between these two machines, encrypted, and have secure communication. The thing is, in this configuration, the IP addresses which you connect to are static and public. Key rotation and everything you have to take care about yourself. And scaling such a network is, of course, more and more work as you add nodes, because for each new node you have to add the configuration to each of the existing nodes, or if you remove one, or if an IP changes, or if you want to do key rotation. So that doesn't scale very nicely. The common VPNs, which are used in enterprises, as you may well know, have a centralized server which manages where you log into, and then it manages your local network settings and applies rules, and all the traffic goes via this central VPN server. This is not how Tailscale does it. Tailscale leaves the traffic on peer-to-peer and adds the control plane for managing all this information. That's their Tailscale coordination server. And that keeps, for example, for your tailnet, that's like the name for your virtual private network enabled by Tailscale, it's a tailnet. This TCS keeps all the public keys and the IP addresses and configures each machine via these coordination servers, so you don't have to. There is a link below for a detailed description of how this works and is set up and what the difference to a traditional VPN are, which you might read if interested. I give you the key facts and benefits here. What Tailscale enables on top of this WireGuard implementation and coordination server is NAT traversals. Without any further configuration, you do not need a public IP address for the nodes you connect. A and B can sit behind network address translation, NATs, and still communicate peer-to-peer over the internet. This is facilitated by using the STUN protocol and some special software. And how this works is each node contacts the coordination server, the STUN endpoints there, and by contacting it, it reveals the public address and port number that the NAT device has given this. So on the other side as well, and then this information is exchanged, and A and B know which public address and port number to use for traffic from A to B and B to A, vice versa. This works as long as you use a single UDP socket to do all this communication, because if you open another socket, you will get in the network address translation a new port number assigned or even a new address. So this is some very clever software in there which makes this work. So we can have a tailnet with hosts that do not have public IP addresses, and Tailscale manages the connection setup. Again, a link below where it's detailed described how their net traversal works. Very nice to read if you're interested in such things. By the way, it's the stun protocol, not the stun protocol, but I figured you have to have a Lego figure in a curl-up presentation, so here it is. There are situations where this stun protocol NAT traversal will fail. For example, one example I try to show here. This is like you have two nodes A and B, and they cannot talk directly to each other because B sits behind the net 2. And on the internet, they arrive all on the same net here, named net 1. And this net 1 does not allow traffic from one of its ports to another ports on the same net. So it has a rule internally to deny such traffic. In this case, Tailscale will notice that the connection via stun protocol is not feasible, and it has a set of worldwide relay nodes, derp nodes they call them, where they select the one most close to you, and this one then relays your encrypted traffic from A to B and vice versa. So it does not do any decryption. It's not an encryption endpoint. It just relays the packets so that they appear for this net device to come from the outside, and the net will let it through. So this is their fail-safe in case the direct peer-to-peer is not possible. And the whole stun net traversal way of doing things has not been invented by Tailscale. And for example, the WebRTC protocol uses this as well, but this has been made by Tailscale to work quite seamlessly without you really noticing. And you can move your hosts A and B over the internet. You can use your mobile phone with Tailscale in a tailnet. And you can, on your phone, you go from your wireless LAN to a cell network, and it just will continue working magically. It's very nice. The tailnet you establish with Tailscale is yours per default. So you sign up to Tailscale via a public identity provider, via OAuth. For example, your Google, GitHub, or Office 365 account. And all nodes you sign up are bound into your telnet. So on each node I add to the network, I log in via or give access via my GitHub account. And they all got then added to my telnet. But you also may give access to another telnet for a node. So you can select one of your nodes in your telnet and say, like, share this node with someone else. It will generate an invitation link, which you then send to your friend. And that allows access to this telnet node to your friend. There are some security restrictions in place when you share a node, so that not your whole telnet is exposed to a friend, just this one node. And it will list all people you have invited. Here I have another telnet made with my Google account, and it will all list for this node all people you have given access to it, and you can revoke it at any time. So now we have a network, our telnetwork, which works globally without public IP addresses. What else can we do with telnet? One feature that Tailscale offers is Magic DNS, they call it, which means they can provide domain names for your telnet nodes. And they give you a subdomain inside the ts.net domain, which you can select They give you a range of proposals. You do not type the name yourself, and you choose from these proposals. You can, if nothing suits you, you can spend some time refreshing the page to give more alternate names. I ended up with Sheep Mountain for my tailnet for whatever reason. I'm not sure any longer myself. So Sheep Mountain Tailscale.net is the top domain for my tailnet nodes, and VPS, Sheep Mountain.net, is my public VPS server, which I've hosted somewhere in the cloud. And the nice thing is then you can use this name internally. It will resolve these to your proper telnet addresses. And when you share with friends, you also get access to their magic DNS names. So you can use them as well in a shared net setting. The super cool thing is that Tailscale can provide you Let's Encrypt certificates for these hosts. So you can have valid, these are not like private, self-signed specific. These are public Let's Encrypt certificates, which are trusted by curl and your browser, and you can use them for your internal nodes. The thing now is that when you have Tailscale installed on the machine, there's a Tailscale daemon running, and this Tailscale daemon has a local API via Unix domain socket, for example. Here. This socket on a Linux machine gives access to the Tailscale daemon's API, and you can contact it via curl. You say like use the Unix domain socket and connect to localhost, and it will give you an answer. This is the local Tailscale daemon. Using curl to connect via to HTTP via Unix domain socket is of course implemented by curl. Curl has everything we need, of course. So we can use this local API to get the certificate that Tailscale generated for us. This is the endpoint, local API v0 cert, and then you give the domain name. And this will give you the public certificate and also the private key that belongs to it, because you need both to make HTTPS work, for example. But as we see here, if you just access it, we get a forbidden, because by default, only root may have access to this endpoint in the API, which is of course very nice, because we don't want anyone to have access to the key. So, how can we use this for an Apache server, which runs inside our telnet? Well, I extended the Apache Acme solution, which we have in the server, to speak to the local telnet, Tailscale daemon. What you do from the next version, which we release quite soon, is you can, for a managed domain, for those familiar with how Acme in Apache works, you specify a managed domain with domain names. And in this case, we say like our certificate protocol for this is Tailscale instead of the Acme default, which we talk with Let's Encrypt. So you say this is Tailscale, and the Apache server will contact the local Tailscale daemon and ask for a certificate for VPS sheepmountain.net. Then we set up the virtual hosts, blah, blah, and reload the server. It will get the certificate. And we have in our Tailscale network HTTPS working with our Apache server from all our telnet nodes, Tailscale nodes. And it will be accepted by browsers and curl just like any valid public website. It's a real certificate. There's no other things you need to do. You can just use it and you have a secured connection. Inside the Tailscale secured network connections anyway, but you have a secure HTTPS. For the record, the Caddy server was the first to implement this, and that's where I got the idea from to do this also for Apache. So we have our own private network without public IP addresses, shareable with friends, and with valid HTTPS. This is all very nice so far. I mean, even these two gentlemen cannot really find a fault in that. With very little configuration, we have our own internet on top of the global internet, which is secure, P2P, end-to-end encrypted. We have DNS names for everything. We can use DNS names for all hosts that are shared by friends, we have trusted HTTPS. That's not bad. What more can we do? Maybe we want this VPS sheep mountain TSNet only accessible from our telnet. However, the VPS server I have in the cloud has also a public IP address where I host other domains. So let's say this host has the public IP address 1234. Then we could use curl to contact 1234 and ask for access to VPS sheep mountain TSNet, as you see in this command line. And indeed, our Apache server will honor this request and give a response. This is not exactly what we want. We do not want our VPS sheep mountain server to be accessible from anywhere on the internet. Curl is simply too powerful here. Should consider nerfing this specter. Tailscale daemon, which we used before to get the certificate, also has another API endpoint, which is very interesting, and this is a whois service. This lets you ask the Tailscale daemon who is behind an address and a port number, where you, for example, a connection is coming from. So someone connects to your host, you can ask the Tailscale daemon who is connecting here. So if we give like a public address port, Tailscale daemon will say, I do not know this, which means this is not coming from Tailscale, this connection. If we give a connection coming from Tailscale, however, like this one, we get an answer with a JSON response, and that JSON response will tell us who is behind this connection address. What Tailscale gives as a response, the JSON, is quite verbose, quite lots of information. I extracted some interesting ones here. You have the node name that is connecting. This is like another of my machines. And you have the user profile to which belongs to this node. So if I signed up this node using my GitHub account, all connections from this node will give this information. So now we can see when someone contacts our Apache server, who is behind this connection. Either someone outside of Tailscale networks, or we know who inside the Tailscale network is connecting. And I wrote a little module, mod authorization authentication Tailscale, which is available on GitHub. And that uses libcurl to contact the local Tailscale daemon and ask for incoming connections like who is behind this. And with this module, if we load it into the server, we can, for specific areas on our machines, for example here, location / like all locations inside VPS Mountain.net, have the require statement. We require here that the Tailscale telnet is icing GitHub beta Tailscale.net. So this is like every of my Tailscale nodes will belong to this telnet, and I can say require Tailscale telnet for this telnet, and only my nodes in my telnet will have access to this location. You can use another statement like require Tailscale user to give restrict access to a specific user ID which is delivered via Tailscale, or like with a star to any Tailscale user. So example, location friends, that would be a location on my host where only Tailscale users, whoever I give access to, not every Tailscale user in the world, only Tailscale users I share node access to VPS with, and those telnet users have access here. And all other people who contact the server will get a 4.3 access denied. So now I have my private host protected against the outside, even though it has a public IP address. And I can control the specific locations on this host, how do I give access to it. Supported directives so far require Tailscale Tailnet. We have seen that before. Tailscale Node, where you restrict access to a specific node name, or as you've seen, Tailscale User with an authenticated user ID. This works like other auth modules in the server, like the LDAP module. So you can make multiple statements, and one of them needs to be true to give access. So I can make a location project where, for example, if Bacter would be, or I have a Tailnet and I invite him, or here I have a location where only myself and Daniel can access it. Another use for this module is you can use it for authentication. You can say, like, here the authentication type is Tailscale, and we require just a valid user, which would mean any Tailscale user can have access here. And additionally, we take the Tailscale user ID, which we got from login name. We populate the server's remote user variable, which is forwarded to other applications which we host behind the server, for example, and you can use that as a sort of login. It's not as secure as a password login, but of course it's very useful because you can differentiate on your Apache hosted application who is connecting. Is it Bacter? Is it icing? Is it somewhere else? And the application can use a username to provide whatever it wants to do. So in summary, with a very few work and configurations, we have our own little internet, global internet. Wherever we go, we can fly around the world. We will keep the connection in our Tailnet and have connectivity like we are at home. We have valid HTTPS for these hosts. We have authentication and authorization configurable for these Apache in this Tailnet. And we can share certain access points with friends and in their Tailnets. And we can control who sees what here, just using Tailscale and a bit of curl and Apache. And I think that's very nice, and there are probably lots of ideas around this, other than just sharing images of cats. Where you can collaborate and share information and manage your servers in a very user-friendly, nice and secure way. And this is what I wanted to present you here. I think it's very exciting, this whole Tailscale thing. And it's very nice and easy what they provide and what curl provides to integrate this into a very nice solution. Thank you very much.